So in this video of Chapter 5, the periodic table, we are going to take a look at the first three components of the chapter in your text. So the development of the modern periodic table, what periodic law is, and then groups and periods of the elements, and really how the periodic table is labeled. So on this slide, I'm not asking you to remember the dates, but I would like you just to take a minute or two and review some of these transformations in our periodic table and think about how the ideas were changing based on what we knew. So in the early 1800s, we can see the German chemist Dobereiner was noticing that different elements could have similar properties, and he was grouping elements with similar properties in groups of three called triads. Now, so this idea that different elements can have similar properties is foundational in our modern periodic table, and it is really what periodic law is about. And we'll learn more about why elements might have similar properties later. The mid-late 1800s, we see Newlands. So the suggestion there is we know 62 elements. We can arrange them in groups of 7, and we'll start from the lowest atomic mass up to the highest atomic mass. So we're still having these arrangement of groups, and we're going to now order them by atomic mass. Okay, and atomic mass is something on the periodic table, but it is not how the modern periodic table is organized. The Russian scientist Mendeleev, whose stamp is on the front of the first slide of this presentation, he proposed that the properties repeat at regular intervals of different chemicals. So you would see these different chemicals with similar properties, and it wasn't a chaotic accidental repetition, but rather a periodic repetition of the properties. So there was a pattern, basically, to the similar properties. And again, he's talking about arranging them in order of the atomic mass, so from the lowest mass to the highest mass. Now, Mendeleev, so here is an idea. Now, his wouldn't have been a computer typed out one, but here is what happened. So you see there's groups, 1 through 8 in Roman numerals up here, and then he was looking at the compounds that these elements formed with oxygen, and he noticed a pattern. And so he was grouping them from the lowest atomic mass here, and as you go across, you'd get down to the highest atomic mass here, and he was grouping them. Now, what I always find so interesting is you'll see that there are places where he left space. And I think it's because there wasn't an element there that matched those chemical properties. And so with the understanding that maybe not all the elements were known, there were empty spaces left. So this starts to look similar to what we think of as our modern periodic table. So in some ways, although Mendeleev wasn't the first person to think about think about how to arrange elements, he is kind of given the title like the father of the modern periodic table, in the sense that it is what we have now is similar to what he imagined. Now, the idea that the chemical properties of elements repeat is called a periodic law concept. So now we're out of the 1800s and into the 1900s, early 1900s. And so with this discovery, he discovered that nuclear charge increased by 1 for each element on the periodic table, the nuclear charge. So if I can remind you, in the nucleus, you have protons and you have neutrons. And so what this is saying, and I don't think in 1913 they didn't know about the neutrons yet. All they really knew is the positive charge in the nucleus. So they didn't know about the neutrons. But we know there's protons and neutrons in the nucleus, and then electrons outside the nucleus. And so this idea that each subsequent atom has one more increase in charge would then indicate that the protons are changing for each subsequent atom. So you can see here that if you arrange it by nuclear charge rather than mass, then the trends on the periodic table are better explained. And so our current periodic tables are arranged by the atomic number. And remember, the atomic number equals the number of protons, which would then correspond with the nuclear charge of that atom. And so this idea by Moseley is how the modern periodic table is arranged, not by increase in atomic mass, but by increase in the atomic number or the number of protons. Now, the periodic law, what it's saying is that the properties reoccur in a repeating pattern. And so you can see with Bohr having the idea of electron energy levels, the periodic table took on the form that we now would associate with it. And we're going to see how those energy levels are, because that was all about electrons, remember? So we're going to see how electrons influence this periodic law, or the regular repeating pattern of the chemical properties. So I've mentioned some of this. It says the elements are arranged by increasing atomic number, our current periodic table. And we call elements groups that are in a column, and those elements in groups have similar chemical properties. This is the periodic law. And then the horizontal rows, so the ones going across, are called periods. Now, there's not a corresponding property, like chemical properties are not similar across a row or a period. They're only similar in a column or a group. So what I did here is I brought in the periodic table that we're going to use on our exam, and I want to label it with all the things that I can think about labeling. And now the slides are in this video, and we'll go through it, but I want to just take something that you will see on the exam and label it. So first of all, what I want to do is just remind you that these numbers here, I didn't change my marker. Let me change it. That right there is the atomic number. Okay, so the periodic table is arranged in order of atomic number from left to right as you go down. Now they're organized in what we call groups or columns, and I'm just going to come over to this one here. So this would be an example, this right here. This is called a group. So all of the columns would be called groups. Okay, so it's the up and down. And groups have their own numbers. So they have a traditional, which would be a number with a letter, either A or B. And then the more modern is just numbering each column 1 through 18. So if I said group 6A, then you would know which column it's in. Or I could say group 16, you would know which column it's in. Now the horizontal, so this right here, this row is called a period. And the periods on this periodic table are labeled 1, 2, 3, 4, 5, 6, 7 as you go down. Not all how the elements are organized is uniform, but how periodic tables are labeled is not necessarily uniform. Sometimes there's adaptations if the periodic table is used for a specific area of study or a specific job. Then they might put different information on it. The overall organization of the elements would be the same. So from the previous slide, we had these three words: atomic number, group, and period. Now, the periodic table is broken into several large groups, 3 to be exact, and I'm going to use a highlighter to highlight each one. So the first group is called the representative group, and it is everything, all of the tall columns. So it's everything that has an A on the top of their column. If you look at the group numbers on these columns, they have a number and then the letter A. But it's all the tall columns, and those are called representative elements. In my other book, they are called main group. I'll just put it underneath it in case in some other video I say the word main group. There, it's the same thing. One's probably just more modern. So they're everything that's yellow, all the tall columns. Okay, then the short columns on the main body, those are called transition elements. The transition elements all have B's as their column. So they have, if you look at on the top of their column, they have a number and then the letter B. Sometimes they're called transition metal elements. Whether the word metal is there or not does not change what it is. So it's just a variation. And I'm just outlining the blocks instead of coloring it all in. Then finally, in terms of the big blocks, there's only one more big block. It's down here at the bottom. And if you notice, this block is taken out of the periodic table right here. Like if you look at the atomic numbers, you'll notice it goes from 57 to 72. Well, 58 is right here. So these are taken out. I think it's just for the integrity of the overall shape, because remember, in the groups, there's chemicals with similar elements, and if we were to include these intertransition elements, it would, in the representative elements, it would throw those groups off. So this section is taken out, and they're called inner transition elements or inner transition metals. And again, if the word metal is there or not, if they just say inner transition or inner transition metals, they're referring to the same thing. So those are the big groups that are in the periodic table. Now, there are 4 groups that have their own names, and I'm going to write them along the bottom, and then I will color it in once we get going. So group 1 or 1A, it's the first group, is called the alkali metals. It's 2 words. I want to try to put them all down here, so that's why I squished it. Group 2A or group 2, I'll try to be consistent. 2 or 2A. So that's the second group on the periodic table. These are alkaline earth metals. And I already see I'm going to have trouble writing it down here, so I'll go up the line ahead. The other 2 are on the opposite end. Let me just highlight these 2 while we're doing it. So I'll put these in blue, and I'm talking about this right here. Oh, and I made a mistake. hydrogen is not included as an alkali metal. It's in the group there, but it is not, and it shares some properties with those, but it's not considered an alkali metal. It's kind of in its own space. And then the alkaline earth metals here, that's the second group, and it is all of them. So those two have their own names. Now, on the opposite side of the periodic table, group 17 or 7A, those are called the halogens. And then the one right next to it, 18 or 8A, are called the noble gases. So let me highlight those. So I'll highlight the halogens. They're right here. And then I'll highlight the noble gases. Oops, I almost used yellow again. Let me use a different color. And so when we look at the periodic table, not only do we have these big groups, the representative, the transition metals, the intertransition metals. So those are big categories, big blocks. We have 4 groups that have their own specific names. Now, at this point, it really does become memorizing, and a recommendation might be to take a blank periodic table and try to relabel where the things are. This is not a conceptual idea here. It really is just a labeling idea. Now I do have slides here, and these are from your textbook. So let's just review it, and you can see it in a different way. So it says the 8 tall ones, everything with an A, are called the representative elements. And then you see or main group, it's there as well. The ones in the middle, the center, that have a B. And this periodic table that is displayed from your text, they use Roman numerals instead of standard numerals in front of the A or B. Those are transition metals, and then the one little section that's out is the inner transition metals. You can also see on this slide, if it's easier for you than what I did, they have the 4 first 2 and last 2 groups labeled alkali metals, alkaline earth metals, noble gas, halogens, and noble gases. Now here's one word that I did not use, lanthanides and actinides. It's because this lanthanum and actinum are right before those. These are, I call them old-timey names for the 2 rows in the inner transition element. So lanthanides would be the first one, and actinides would be the second. I feel like in most of the things we don't come across those words very much anymore, but here is a reference in case you do as to what it is what it would be speaking about. And again, so here's another slide, which I'm going over these last 2 quickly because I just labeled the whole thing for you. Pause at any time if you're trying to take notes and look at it. But here again, it just labels the 4 groups that have their own names. So one thing we can do is just practice. And so you would need a periodic table for this. So if you don't have one, go get one or pull one up on the computer, because you to figure out the symbol of the element that fits each description, you do have to have a periodic table. So I will pause. I'm going to pause right here because I actually want to get a periodic table and put it on this slide so that we can do this together. So I'm going to pause, get that periodic table, and be right back. Well, for you, it wasn't a pause probably at all. I did have to pause, but that's why the little periodic table in the corner popped in there. Now, it might be kind of hard for you to see, but I'm going to do the best I can to show you what's going on. So, letter A, the alkaline earth metal in the 6th period. So, alkaline earth metals are this second column. And so, the 6th period, it's 1, 2, 3, 4, 5, 6. So, it would be right here, and it would be barium. Now, this periodic table is really tiny, so if I mess up, just go with it. The noble gas in the third period. So periods are rows. So 1, 2, 3, that's the third period. Noble gases are over here. So if I go across the third period, then I would have argon. The actinide with the highest atomic mass. So the lanthanides are on this row, the actinides are on this row, and so as we go across, it's going to be this last one, which I think it's LR. I'm going to look back at the other periodic table if you don't mind. Yes, LR. That's because that's such, I even have my reading glasses on, and that is so tiny, I was questioning myself. Now, semi-metal. Okay, so I think it's good that this problem that I had brings out semi-metal. So semi-metals, so in group 3A, the semi-metals, we haven't talked about yet. So, I wonder if I was supposed to do that for this. Okay. We're going to come back to this. Come back. And then the alkaline earth metal in period 2. So alkaline earth, again, is the second column. So period 2 would be 1, 2, so it would be beryllium. Now, semi-metals, and I didn't see it in any of the other slides, so I'm wondering if that is not in this particular chapter. But I'm pretty sure it's not. Just 1 second. Okay, so I don't think semi-metals is in this. So I'm going to take out this question and not get ahead of ourselves. I'm just going to take that one out. There's metals, nonmetals, and semi-metals, and so I don't, since we haven't talked about metals, nonmetals, and semi-metals at this point, I don't want to add that into this conversation. So we're going to get that, but we'll get it in a little bit. So here's another practice. Which of the following, this is multiple choice, is a halogen? Pause and look at your periodic table. And of the halogens, let me just pull in another periodic table for us. I think it will let me, sorry for that. Okay, here we go. So calcium is here, oxygen is here, argon is here, and chlorine is there. So halogens are right here, 7A. So the answer would be chlorine. Calcium is a alkaline earth metal. Oxygen is just in group 6A. Its group doesn't have its own name. And then argon is a noble gas. Which of the following is a representative element? I'm going to grab us a periodic table. Sorry, I should have put them on. I wasn't thinking very clearly when I organize it. Now, representative elements. So the representative elements are all in the tall groups here. That's representative. So it would have to be in these groups here. So when I look at representative, let's see. Copper is Cu. That's here. It's not. Sodium is right here. It is. Iron is right there. It's not. And uranium is right here. So the answer is letter B, sodium. So from this video, what I want you to do is to be able to label the periodic table, and then given questions like the ones we've just done, identify different elements and what categories they would fit into.